Okay, 1.9 is everyone's favorite section of the book, addition and subtraction with fractions. Now, this is something that you should be have no problems with, absolutely, because I'm sure that you spent a ridiculous amount of time on it in middle school and in 1A and probably in 1B. But just for fun, we're going to go over it again because I have been shocked at how difficult this is for some people. So, addition and subtraction with fractions, unlike multiplication, okay, we cannot just add straight across. We all know that we have to have a common denominator. So if we have a common denominator, our life is simple. Then we just add the numerators, we keep the denominator the same, everything's good. Okay, so in the top example, we have 3/4 plus 2/4. The denominators are the same. I just add the numerators and I get 5/4. Okay, no problem. And then of course, if it was subtraction, then I would just subtract the numerators. I'm going to leave out subtraction when I'm talking about this because, as we said before, subtraction is basically just adding a negative. So I'm not really worried about that. I want to get the denominator thing figured out more so. So the next one, we have a problem. Okay, we don't have the same denominator, so we have to fix that somehow. And the way we fix that is we find the least common multiple of the two denominators. So this raises some more concern because some people are confused by what a multiple is. So a multiple is not a factor. Okay, when you think of factors, you're going the other way. You're thinking of what do I multiply to get this number. Multiple is what can I multiply this by to get something else. All right? So the multiples of 6, for example, would be 6, 12, 18, 24, and so on. The multiples of 3, so let's just write those down. 6, 12, 18, 24, and so on. The multiples of 3 would be 3, 6, 9, 12, and so on. So when I say common multiple, I'm just talking about as long as the same number shows up in both of these lists, it's a common multiple. So 6 would be a common multiple. 12 would be a common multiple. And you would have several more as you continued those lists out. Okay? And actually, every multiple of 6 will be a multiple of 3. But anyway, so common multiples show up in both those lists. The least common multiple then obviously would be the smallest number that shows up in both of those lists. So for this one, it's obviously 6. So my common denominator is going to be 6. For this, I'm going to go ahead and write my problem as something over 6 plus something over 6. When we're dealing with simple fractions, you don't have to go through all these steps. Later in the book, we're going to be doing rational expressions, adding and subtracting rational expressions. And instead of a 6, it's going to be, x squared times the quantity x plus 4. And I want you to write it like this. So now that I know what that common denominator is, all I have to do is make the change so that this obviously is going to change this value right here. So the 5 over 6 is the same. I'm not changing anything there, so I'm going to just rewrite that one. 1 over 3. So I have to make 1 over 3 equal something over 6. Okay, how do I do that? Well, a couple ways to think about it. This is the time, finally, that you can cross multiply, right? Because we have a proportion set up. Or you can just think to yourself, what did I have to do to this 3 to get to 6? The answer is obviously I had to multiply it by 2. So whatever I do to the denominator here, I need to do the numerator as well. So 1 times 2 is 2. Now I have 2, 6 plus 5, 6. Denominators are the same. Just add the numerators and I get 7 sixths. Okay? Simple. Now, like I said, I hope that by this time, as a senior, you don't have to write the lists and circle the common multiples and find the least common multiple. and set all this stuff up. Okay, I'm hoping in all your tests and on your quizzes and on your homework, I'm hoping that you just recognize that this is 2/6 and add it together. If you don't, though, it's okay. Just know that this is how you do it. If you need to do this for a while to get it figured out, go for it, by all means. If you can do it in your head, do it in your head. So the next one, we have 3/4 plus 2/3. Okay, now they're both going to be different. So 4 and 3 are my denominators. So what is the least common multiple of 4 and 3? If you are too lazy to find the least common multiple, you can always just multiply the denominators, and that will give you a common multiple. It might not be the least common multiple. It might be the least common multiple. But that's always kind of a fail-safe. So if you can't figure it out, and you're tired and you're stressed and you're running out of time, just multiply them. No problem. So if I multiply 4 and 3, I get 12. In this case, it turns out that is actually the least common multiple. So 12 is what I'm dealing with. So I have something over 12 plus something over 12. Now I'm going to kind of skip a few of these steps that I did before, and this one this is more in line with what I would expect you to be doing right now. So what did I have to do to the 4 to make it a 12? I had to multiply it by 3. So since I multiply the denominator by 3, I also have to multiply the numerator by 3. So 3 times 3 is 9. Okay, what did I have to do to the 3 to get 12? I had to multiply it by 4. 3 times 4 is 12. I have to do the same thing to the numerator. 2 times 4 is 8. Okay, so now I'm set up. Now I'm good to go. Same denominator. I just add the numerators. 9 over 12 plus 8 over 12 gives me 17 over 12. Okay, this is how I want the answer. I do not want you to make it improper. I don't want you to, I don't want you to make it a mixed number. I want you to leave it improper just like it is. Okay, no problem. If you can simplify it, simplify it. If not, leave it alone. Now the next thing I want to talk about, and I want to make sure that you're completely aware of this, is that you've got to be able to do this without a calculator. If you have to take the time to put in your calculator 3/4 plus 2/3, you're not going to be able to succeed in solving these problems quickly enough to get a good score on the Coyote. You've got to be able to do this in your head. So the only way to get better at it is to do these practice problems. So don't just sit there with a calculator and put these problems, plug them into the calculator and see what it tells you. Do the work to figure them out. I promise you it'll get easier. It'll go a lot faster. Your book basically explains it pretty much the same way I just did. They do a few extra things in there. They talk about doing actual prime factorization and then figuring out what divides different parts of it. If the way the book explains it, and this book is good about explaining things pretty simply, if you like the way the book does it and you want to do it that way, that's fine. Okay. However, you've got to do it to get the correct answer without putting it in the calculator is fine with me. So if my way works, fine. If your way works, fine. If you've got some ridiculous thing they taught you in middle school or something, go for it. And I think, well, let's do one more. Example 14 on page 72 is ask you to add 4 over x plus 2 over 3. So what happens to people, it seems like to me, is everything's hunky-dory and fine, and we get all this, okay, and we're doing fine with adding these fractions, right, these numbers. But then I throw a variable in there, and it's like the wheels fall off. Follow the exact same steps, okay? So what did I say was the fail-safe? If you can't figure out what the least common multiple is, what can you always do? You can multiply the two denominators. So we're going to do that. So x times 3 is 3x. So this is going to become something over 3x plus something over 3x. Okay? Now you have to ask yourself the same questions. We're following the exact same process for all these problems. It's just that now we're adding variables, we're adding different things in. So what did I have to do to this to get this? What do I have to multiply x by to get 3x? Obviously the answer is I multiplied it by 3. So if I multiply the bottom by 3, I have to multiply the top by 3. So 3 times 4 is 12. What did I have to do to this to get this? I had to multiply 3 times x to get 3x. So I have to multiply the top by x as well. So this becomes 2x. Okay, so now I add the numerators, I keep the denominator the same. If I don't have like terms here, obviously I can't add them together, so I'm just going to leave it 12 plus 2x over 3x. Okay, that's it. Final answer, done, good. Now I want to go back here and look at what I did. So I said, what did I have to multiply this by to get 3x? The answer was x. So whatever I did here, I had to do in the numerator as well. The reason we can do this and the reason this works is because look what I've created here. Okay, I have a fraction that I'm multiplying times 2/3, and that fraction is x over x. The reason I'm able to do that is because x over x is 1. So when I multiply 2/3 by x over x, I'm not changing the value of 2/3, but I'm making it, I'm changing its form into something that I can work with. Because I've got to have a common denominator, so I know I've got to put that x in there. But by multiplying the top and the bottom, I'm keeping it x over x, which is 1, which does not change the value of this 2/3. If you ever find yourself trying to multiply it by something that's going to change the value of this fraction, stop. You can't do that. All right? On this side, we multiplied by 3 over 3, which is 1. Which does not change the value of 4 over x. I hope that makes sense. If it doesn't, I'm here for questions.